Did you know every time you use your phone's GPS, you're relying on Albert Einstein's theories? That's right, without his ideas, your GPS would be lost. GPS satellites use Einstein's relativity to keep their timing accurate. Newton's laws are great for everyday life, but not enough for the precision GPS needs. GPS works by measuring the time it takes signals from satellites to reach your device. If those satellite clocks aren't perfectly synced with clocks on Earth, your location could be off by miles. Einstein's theories showed that space and time are connected, and that gravity and speed can change how time flows. This isn't science fiction. It's happening right now every time you use GPS. Let's dive in and see how Einstein keeps your maps on track. Here's the challenge. Time doesn't tick at the same rate everywhere. Einstein discovered that how fast a clock ticks depends on its speed and the gravity around it. GPS satellites orbit over 20,000 kilometers above Earth, moving at 14,000 kilometers per hour. Their atomic clocks tick at a different rate than clocks on the ground. If engineers ignored these effects, GPS would fail within minutes. Your device calculates your position by measuring how long it takes signals from at least 4 satellites to reach you. Even a tiny error, just a few billionths of a second, can throw off your location by hundreds of meters. That's why precise timing is everything for GPS. Let's see how Einstein's relativity changes the game. Einstein's special relativity says the faster you move, the slower your clock ticks compared to someone standing still. For GPS satellites moving at 14,000 km/h, this effect is real. Their clocks run slower than those on Earth. Specifically, satellite clocks lose about 7 microseconds per day due to their speed. That may sound tiny, but even a microsecond error means your GPS could be off by hundreds of meters. Without correcting for this, GPS would quickly become useless. But speed isn't the only factor. Gravity also bends time. Let's see how. Einstein's general relativity showed that gravity slows down time. The stronger the gravity, the slower the clock. GPS satellites are high above Earth, where gravity is weaker, so their clocks tick faster than those on the ground. This effect is even bigger than the slowing from speed. Satellite clocks gain about 45 microseconds per day due to weaker gravity. So special relativity slows the clocks, but general relativity speeds them up even more. The result? Both effects must be considered together for GPS to work. It's a cosmic tug of war on time. Let's see how engineers solve it. Add it up. Satellites lose 7 microseconds per day from speed, but gain 45 microseconds from weaker gravity. A net gain of 38 microseconds daily. Before launch, engineers set satellite clocks to run 38 microseconds slower than ground clocks. Once in orbit, the effects balance out and the clocks stay in sync with Earth. Without this correction, GPS errors would add up to 10 kilometers a day. So next time you use GPS, remember, Einstein's century-old theories are guiding you. Science isn't just in textbooks, it's in your pocket, helping you find your way. Thanks, Einstein. Science rules. Want more everyday physics superpowers? Hit subscribe and drop your wildest "how does that work" question below. Your idea could orbit into our next episode.